Okay, sorry for delay. Um, so today, the second time for intercepting communications. I know many of you are still working on reverse engineering, so we decided to extend one day for the server issues. Um, Also, as I announced it, next week we have a we will have a summer break, spring break for 1 week. So during the break, there's no any assistance for you, no dissertation, no office hours, and no response on Discord. Okay, from our course team, TA or UGTA or professors, we will have a break time. And then, yeah, the May 13 gonna be the due for this intercepting communication. So yeah, manage your timeline, not too late, or don't miss any module challenges by due date. Okay, today let's see the challenge first, and then what kinds of things we have to learn this class. Okay. Um, so intercommunication. So I think I covered level 5, right? So by Tcpdump, I think we can use that for the purpose of solving these challenges. So let's see level 6. So start it to practice. Okay, and let's start the shell. Closed. And practice. I see. Okay, let's use workspace. Okay. Okay, let's check the challenge first. So challenge run. Okay, so module 6 monitors low traffic from a remote host. We learned how to check our address like IP and phone number or the Ethernet address, right? Depends on the layer. We can distinguish, identify the address, right? Using ipconfig or ifconfig, right? IP add show commands. So we can easily get that network configuration information. And then we can try to connect to the target server or host using tool what? Netcat, right? So Netcat make TCP connection or UDP connections. Also, it made our server to be in listen mode. So we can also receive some packet from the remote server. In this way, we can connect and listen from a remote host. So that was the level 1, 2, 3, maybe. And then we try to scan, find which server host live or not. What's the name of the tools? Can you remember? These tools draw the map of network. So we call that nmap, network mapper. So nmap, right? So nmap has some options to check the port is open or not. So we use the options small s and n. We call that the sync scan. So we will learn about the sync or ACK, three-way handshake in the TCP protocols. So using that, yeah, and the mmap show us the alive, which host is alive, open any port. So after that, we try to connect that live uh, one. In that, that is the mmap usages. And then also, we learned the TCP dump, right? TCP dump specify the interface, the network interface. Network interface, that's a LAN card on our laptops, right? Sometimes laptops are connected by Wi-Fi. There's a Wi-Fi LAN card, and also it will be connected with a wired network, right? In the case the Ethernet, the jack, we call that RJ11, RJ45. That's the specification names of the jack, the wired network, wired Ethernet network, Ethernet network. So uh, TCP dump so can snip the listen passively the traffic go through the interface, right? So we also the using TCP dump save that traffics and unload that traffic on the tools. What's the name? The GUI based tools. Wireshark, right? So Wireshark shows the packet with a very nice visualizations, the visualized representations of each layers from Ethernet, IP layer, and TCP layer. And also we can see the application layer in Wireshark. Yes, that's the review for last class. Today, to monitor the traffics, we can use the TCP dump, right? In GUI tools, we can also use the Wireshark. Which one is more convenient to you? Which one do you like? TCP dump. Great. Yeah, TCP dump. That's the powerful tools. So let's connect that challenge again here. Okay. So in this level 6, request to the monitor the traffic from remote host, right? And yeah, my host 10, right? My host 10.0.0.2 already receiving the traffic from 10.0.0 from a remote host. I don't know which host. So sometimes we can in the real yeah, the ALPA shows what? ALP shows the cache tables the have a sessions connected with this server, with this host. So I don't know the 66 is which one, but I can at least my MAC address started from BE, right? So 66, that's not mine. And yeah, so this 66 MAC address, yeah, that assigned with this IP. 10.0.0.3. So, oh, this host received the traffic from a remote host, the IP address 10.0.0.3, right? So let's check the thing 10.0.0.3. Yes, correct, right? Or we can also map SN option, and the current address domain maybe, yeah, and the C class. Uh, okay, let's is so as a result of this scanning, so we know, oh, 10.0.0.3 is live. Okay, that's the way. What kinds of what kinds of so host, how many hosts are alive and open in this network. So network, I explained last class, the sub network, right? Sub network. Sub network is to manage the network. The way to manage the network in small scale. We cannot manage the huge scale in one domain because, yeah, that's inefficient. A lot of load and performance issues and conflict and the management issues are there. So network designer, they divide that huge network in a small scales. So the sub-networking, that is the perfect way to uh, divide the network in one small network. We call that sub-network. Okay. So here we can see the IP address, IP eight IP address and two host. Uh, oh, scanned 8 IP address and the two host is up, right? The first one 03 and second myself itself 02. Okay, so how can we receive? How can we uh, check these hosts receive the traffics? Yes, we have to monitor, right? Using monitor traffics using the TCP dump. Okay, the main TCP dump. So we frequently use the I options. What's the I? Where's the I? Mm, can I find? Yeah, this is the one of the options maybe, and we can see some, yeah, A printed in ASCII, right? And C, we can define the number of packet to capture to monitor, and um, E F F H I, yes, dash I indicate the interface, the name of the network card, right? How can you find that? IF config, right? And I'd like to see one more options. Yes, the V or the VB means they show the more informative informations. If you use these options, dash V or dash VB or dash VVV, yeah, the verbose mode. So they show the more informative information metadata. Yeah, dash W, the write to file. So if you monitor and capture that packet, if you like to save, write into some the files, you could just specify the name of the file after dash W. In that way, you can save that traffic, and that files can be imported to the Wireshark or any other network analyzer tools. So that's the broad descriptions, and also so in this case, how can we monitor the interface? Let's check the interface first. I have config. Interface name, what is that? ETH0. What is the LO? Yeah, localhost, the loopback test. The network card or network setting is okay. We need to check that test, so we can call like a uh, yes, uh, like that. We can check the network uh, configurations using this. And how can we capture that? TCP dump. Actually, the TCP dump access the network device, right? Physical network device. That means you need you need admin privilege, the root admin privilege. But in this case, in the challenge mode root, I already root, so I don't need to type the sudo. Uh, Actually, we need to sudo TCP dump, but I already root in this virtualized network space. Um, that's the assumptions in our challenge, right? TCP dump. What is the interface name? ETH0, either 0, right? And what we need to that? What else? They mentioned about the port. Yes. What's the port number? 31773. So we just option port 31337. So this is the the perfect options to monitor the interface uh, using the port 31337. Yeah, let's see. Okay, so we cannot read and understand these types, but yeah, something from 003. Uh, we received something from 003, right? And there's some sequence ek. This is the number. Usually, this number is not absolute number. It is a relative number from the start. Start from 0, right? So this is the relative number, and yeah, they show some header informations of this packet, and how can we see this packet more friendly to us? So A option. What is the large A options? What is the A options? Large A, ASCII code, right? So they show the ASCII code like this. So data part convert to ASCII code. What is the ASCII code? That's a standard code, right, in a computer and networks to encode and decode of the letters, the English, or some control letters. So here we can see some letters like this: E4, E5, okay, EPCD. So one more of the options that's a large X. It shows the ASCII and the hexabyte hex streams. Okay, yeah. So this is the more the readable, is it right? So we can save these kinds of packets. How can we do that? Yes, or we can also the direct operations. Let's use the like this WF W options name JJ let's and also okay count 10. Oh, because where am I? yeah, the root. So I need to move my home directory. Okay, and again the commands. So 10 packet captured, right? 12 packets received by filter. So ls check jj pcap. Yes. How can we reanalyze these packet files? We can learn the Wireshark, but this is not a GUI based terminal, so we can use the desktop. Okay, so we can run the terminal and challenge. So we are admin now. So as can you see the JJ pickup, right? So we can import that Wireshark and the JJ cap. So as you see, yes. So exactly there are 10 packets like this, right? Okay. I briefly explain how to read, how to understand the packet in the Wireshark. In the first class, I also showed some basic usage of Wireshark. Today, I also that there's additional some explain. So the frame, that's all the outline of the packet of these pcap files of this packet, the 67 size, right, length. You can expand and Ethernet frame, IP packet, TCP segment. This is the real data, right? Yeah. So in this way, you can analyze the captured packet by TCP dump using Wireshark. Okay. So let's try again to capture the here. Control C. Try to capture that TCP dump more and Ethernet ETH0. Okay. And what was the port? 31337, right? And we use the X, large X and small W and name jj2.pcap. Okay, and this time let's capture those 300. Okay, so now this the command, the capture the packet, the collect packet up to 300, the number of packets. So after that, I will browse that pk file again on Wireshark. Yep. How can we do it without Wireshark? How can you do Wireshark? So uh, one of the ways is manually you can check the ASCII code in the TCP dump. How to say? Um, so to analyze the packet, right? Your question is how to analyze the packet without Wireshark. How do you get the data in the slow traffic? Um, so TCP dump, to see, Tcpdump also has some analytic tools, functions, um, but I so I didn't see the usage files. Yeah, so you can filter. So in the Wireshark, we try to check some uh, the relationship between source and destinations, or what type of what kinds of data they are exchanged, or who sent the data. So identify the source and destinations, IP layer and MAC layers, the data link layers. So uh, TCP dump, I believe they support that kinds of um, functions. But as you can see, we need some the familiar with the usage of options and some the syntax in the TCP dump. Also, the pcap, the produced files by the TCP dump, the pcap file that is the common standard, the network files, network packet files, network format. So other than Wireshark, I believe there are some other tools like a Wireshark. So anyway, this class we focus on the Wireshark to analyze the packet. Okay. Okay. Where? Okay. Yes. 300 packet captured, right? Successfully. And then we are trying to load this packet using Wireshark. Okay. So the Wireshark, I think that's a perfect for any investigations analyzed the packet. I think so. So far, I used only Wireshark to analyze the network packet. So okay, JJ two, right? Okay, this is the Wireshark. Um, so we receive some data. Okay, TCP. And the reset means after reset, the session will be start again. The session, I mean here TCP connections. So connection initiated with this three packet sync. So you can see the this sync plug, right? And sync egg. Okay. And then last one, the egg. So we call these three packet three-way handshake in TCP. Okay. And then after they exchange the data. So one of the the characteristic of TCP, TCP is like okay, let's say, have you ever written some love letter to your friend? How long did you write? How long did you write? Let's say I wrote 100 pages letters. So let's try to send that 100 pages letters by post, by mail. The page, but yeah, 100 pages. That's not good idea by emails, right? By post mails. So what if we send just a part of the letters, move the part of the letters to the postcard? So what are different letters and postcard? The postcard only one face, right? Only one pages. That's not a page actually. Very small amount of the letters can be written in the postcard, right? So TCP, they use the postcard mechanism. So before the sending long data, they cut the data as a unit of postcard. We call that the segment. That's the why we call the TCP segment, not TCP packet. So TCP segment, that's uh, the divided part of long data. Okay. So as you can see, the size, right? That's very small, 66, 7, 66. So that's a byte, the 66 byte. So when we see the MTU in the IF config, right? MTU normally indicate 1,500, but at TCP they use the more small, the less than the MTU usually. Why? Because that's reason of some the efficiency to process that the traffics. So that is the performance issues or yeah efficiency issues. So the divided postcard will should be reassembled in the receive side, right? Receiver side. Sender divide and receiver reassembled in the order of the page numbers, right? So that is the outlines mechanism of TCP. So that's the reason why this TCP packet exchanged frequently like this. So again, how can we figure out the perfect content of the TCP packet? We call that TCP streams, one streams. Let's say the 100 page of letter, we call that, let's call that the letters we need to send, right? In the TCP, they cut that letter in a unit of postcard, right? And give number from 0, 1, 2, 3. The, so that's the, we call that sequence number, right? If we didn't get the number, so we cannot reassemble perfectly, right? Maybe mixed of the contents in the receiver side if we don't know the sequence number, right? So they use sequence number like this. Can you see? Sequence number 7, right? Uh, 1, 2, right? 3, 4, 5, 6. Yes. So sender continuously assign the number to the postcard, the segment, and then the receiver, the reassembled based on the sequence order, number order. So the TCP stream, the long letter, should be reassembled in the TCP receiver side. We say that is the TCP stream. Wireshark, they provide the reassembled features automatically of the postcard. How can we do that? So just you pick one of the data exchange and analyze, can follow the TCP stream. Okay, so here there is a very cannot read, but it duplicated each letter, right? It has duplicated each letter. Why? Because they show the send and receive. Oh, my. Okay. So here I'm okay. Yes, slightly moved. Moved. Here, entire conversation then means yeah it combined sender and receiver data. So let's filter only one uh, directions. Yes. So they show the flags in this way. So level 6, they recast, capture the packet first, and then reassemble the TCP segment, the postcard. Okay, can you do that? Any questions so far? So you must know this feature, or you can also try to just TCP dump. Let's just try. So you can see also we can do TCP dump interface ETH0 and port 31337, right? And X option. Okay, we don't need to save, but try to see. Yeah, we can see the received packet to port 31337 of this host. Okay, so let's see. So here you can see the sequence number, right? The postcard number, they increase, right? 17, 18, 19, 20, 23. Yeah, the reset in somewhere. Okay, again 10, 11, 12. Okay, so maybe you can find some keyword in the data like phone. Maybe is there anywhere? Hey, I cannot see. Anyway, so you can also discover that some meaningful letters in the TCP dump logs without saving. But so these flags is very short. So in these logs, I cannot find. Let's see. Okay. So let's see some theory now. So Wireshark is a packet sniffer and protocol analyzers, analyzer real-time and non-real-time analyzer. Support a lot of protocols. IP version 4, 6, that's a very small part of the supporting protocols and open source. So you can learn the Wireshark in this way. But Wireshark also should access the interface to capture, right? So you need the admin privilege. Yeah, this is the uh, descriptions of screen. Usually this how, what's the color of this one? This green, that's the display filter. Can you see the here TCP double bar and quit? What's the meaning? Only display the TCP packet or the quit protocol. Do you know the quit protocol? What? Thank you. Sorry. Can you see? Okay. So again, so it didn't. Yes. So can you see the here TCP and quit and the operator, the or operator. So display just the TCP protocol or a quit protocol. So they this is the result, the protocol list, the packet list, right? And the frame data panel details and hex view. So Wireshark main toolbar, interface list, and also you can see the capture filter. So there's a two kinds of filters in Wireshark. The first one, display filter. What's the mean? It has a collection of packet based on some display filter. Only extract that filters to show on the packet list. But capture filter. Capture filter means only capture only based on the filter, right? Like I like to capture only TCP packet, so you can use the capture filters. So that's different. So this is the packet list pane, and this is the intelligence scroll bar like IDA, and the packet details pane. They show the layers of Ethernet, IP, UDP in this case, and data, and data byte pane, and the status. Okay. We can find some the string using find features. So yeah, this is the Wireshark, the follow TCP stream. That we assemble the postcard to the long letters. Yeah, the Wireshark perform that. The sample screenshot case like the web pages, right? We can capture the web pages and reassemble the source code, HTML, right? There's some HTML header, and this is the uh, HTML, the text, the body, okay? And also, Wireshark provides some statistical features, like how many packets uh, based on the types of the packet, how many packets are collected, sent, and received, right? And like some the graphical representations. Yes, so very useful. Okay. So and also, so TCP three-way handshake I mentioned. What is this? So let's say the client and server try to connect. So this spec, can you see the this protocol stacks? This is the format of TCP packet, TCP segment. What is the address of the TCP? IP address? MAC address? No, the TCP they use the port number, right? What's the size of the port? 2 byte, right? So 2 to 16. That's the 64K, right? So that's the maximum size of the port number, 64K, maybe 65,000, blah blah blah. That's the maximum size. Source port and destination port. And sequence number, the 32 byte, and ACK number, the header length, and flags, and the window size, the how many packet, this is the size of the packet, the possible size of the packet, and checksum for some integrity check of the packet, urgent point. So these three urgent point options padding. The padding is just the alignment of the packet to make the 20 byte, the header size 20 byte, and data is real data. Let's say the client send the server first the port number, source port, what? 13987, and destination 22. And sequence number, the 6574, ACK number 0. The flags, the sync flag set 1. That means this packet is sync packet. What is sync? Synchronize. So if you like to talk with someone, you have to sync first. What's the meaning? So we need to check, oh, he is available or not to talk with me, right? Like that, we have to sync before the conversations. So this is the first packet to initiate the handshake to sync packet. So in this case, sync flag the set to one. Okay. If the server receives this packet, if he can allow to connect with itself, to receive with ACK. What is the ACK? Yeah, acknowledges. So the client, hello, can you talk? And server, oh, I know you, your IP and your port, and okay, I can talk with you. That's the ACK, not ACK packet. That's the second packet. And then lastly, the client, thank you. Okay, let's start talk. So this is the three-way handshake in the real life, right? Like that, they must handshake that make the connection first, and then they exchange something, the data. Okay. So this is the format of the TCP segments. Okay, so let's check another level 7. Let's move to level 7. Okay, what's the mission? Hijack traffic from a remote host by configuring your network interface. Hijack. Yeah, that's intercepting. The title of this course, hijack. Traffic from a remote host by configuring your network interface. That means we have to manipulate something on our network interface, right? So let's just see the challenge again. Okay, level 7. Let's see the challenge. Run. So we will hijack traffic, okay, and the remote host 10004 is communicating with the remote host 10002. Okay, let's check the remote is live. Let's ping 10004. Yes, it's live. Okay, good. And then, yeah, the 4 communicate with what? Whom? The 2. I will omit the common part of the IP address. Just the 4 is communicating with the 2 on port 31337. Okay, so what I'd like to do first, I check just the remote port 004. And also, let's send 10.0.0.2 ping. Yeah, so 2 and 4, they are live, and my address, yeah, 3. Okay, so everything's all set. And how to so to intercept of these traffics, what can we do? What? So the number 4 server host communicate with the number 2. How can you receive instead of number 2 host the traffic from host number 4? Impersonate yourself. I'm number 2 host, right? Is it possible? Yeah, it's okay because yeah, digitalized the virtual space. We can impersonate as someone. If we can change our identity of someone, right? So in this case, how can we change our identity? In this case, what is the identity to communicate? IP. How can change the IP address? Currently, uh, so my address is yeah 3, right? So let's try to change my IP to 2, 10.0.0.2. Any idea? Anyone has idea? How can you change the IP address? Let's configure our network interface. DHCP? DHCP assigned the private IP dynamically, right? So we cannot control the assigned logic of the DHCP. I'm not sure perfect 100%, but DHCP they assign the IP randomly. But I know they sometimes they give the same IP to the same the MAC address. Anyway, so the HTTP, so we I think that is not easy to assign the specific IP address, right? How can you change? You can configure. Yeah, so we are admin, the you are super user. I can change the network configurations of my network interface and reboot. So my device recognize the new address, new configurations is updated, right? So after that, I can claim, oh, I'm a number two host. Earlier, I'm a number three, but I have to change the configurations. I can claim I'm a number two. But yeah, I know in the network there are number three. Already there's a number two host, right? What happened? That's we call that IP conflict, right? In the early age of the security, cybersecurity, there is kinds of a DOS attack. What is a DOS? Denial of service. So one of the students, maybe you find out my laptop's IP address and set up your laptop with this IP address and the reboot. After that, my laptop cannot communicate normally. So if there are IP conflict in the sub network, yeah, there are some like intermittent, I mean irregular connection, connection and disconnection like that, and there are some packet loss on my laptops. So that's the kinds of error if yeah the dual if the same IPs exist in one subnetwork. So to avoid that, so usually in ASU, our ASU do not allow the change the IP address by the owner of the ASU properties. Okay, how to change IP address in Linux? Anyone knows? Just using ipconfig, I can do that. How to do that? ipconfig. Currently, my IP address is the number three, right? Let's change. ifconfig. So, ipconfig and interface what? ETH0, right? No, we don't need the options, just the ETH0 and new IP 0, 10, 0, 0, 2. Let's check again. I have config. Yes. Yeah, IP was changed. Very easy, right? We can also use the IP address IP address at device div th2 10 0 0 3. The currently only IP the 0 we have IP 2, right? So in this way we can add the IP address okay, add 10 0 0 3. Okay, let's new 0105 and device ETH 0. So sorry, wait, yes, and IP. Yeah, we have two IPs now, number 2 and number 5, right? Anyway, in this way, we can add the IPs or delete. How can delete the IP? In these commands, we change the add command with del, delete, right? And IP config, IP show. Yes, so 5 was deleted. And then, yeah, we change it, our IP address, and we have to listen uh, the traffic from the remote, right? We can use tcpdump, okay? And we should set the interface ETH0, right? And port 31337. Okay, so let's try. Yes, we listened from, as you can see, uh, yeah, 10004. Yeah, receive 10002, right? This way, we receive some packet from remote 004. Okay, so in this challenge, you need to show the how the packet is coming from this laptop, this host. So there's a two host has the address 10002, right? So to distinguish the to identify my laptop received the packet from 10004, we can use the NC, the listen mode, right? And the P, so it's P, source target, no, P 31337. Okay, yes. This way we can say, yes, my host received the packet from the remote host 10004. Okay, this challenge is 7. So any questions? Okay, let's move level 8. Okay. From level 8 module, so we have to send some packet. So manually send the Ethernet packet. The exact name is Ethernet frame, not packet. Okay. So how to send Ethernet packet? So we have to learn another tools, the Scapy, based on Python. Okay, let's move the challenges. Okay. Challenge. Run. So let's read manually send the Ethernet packet. How can you do that? The packet has either types the 0x, the hexabyte, right? 4F, and should be sent to the remote host. This is the destination, right? 10003. Myself, IP address is 10002. IP config. Oh, I have config. Okay, so my IP address. They do not show my IP address. IP. I don't know why. Anyway, ping the target 10003. Ping network is unreachable. I don't know. So this is the virtual network space. So maybe the destination doesn't matter. It is alive or not. Okay. We just send the destination. That's the challenges. To send the packet, we will use the Scapy. So what is a Scapy? Scapy is a Python-based library. So here, okay, let's start Scapy like this. Yes, so automatically uh, run into the CLI mode, command line mode, and we can type some. Okay, let's see the researches in the slide. So Scapy supports creating, modifying, sending, intercepting the packets. So very powerful, and I love these tools again. Also, that's the way install. But our the pwn colleges are pre-installed, and this is the basic commands. The LS Ethernet packet, Ethernet frame, LS IP packet, TCP segment, HTTP protocol, LP protocol, LS and parentheses. They show this header structure. And okay, let's try. Okay, LS. What is the first? LS either. Yeah. Now destination and source the MAC address, the 6 byte address, right? And the types and LS IP. Yes, IP from the version and options. And LS TCP. Yeah. So source port and destination port, right? And SKS number, ACK number. So we can randomly put any value in this field. So that's the packet, the crafting the packet, what you want. Also, as like a ICMP packet, the ping, right? Yes, so from the types and the unused. And also as ARP protocol. Yeah, hardware type, protocol types, lengths. Okay, so like this, they have predefined header structures. So like a library, right? So C libraries or Python libraries. So based on this, uh, we can make the packet easily. Here we have some created sample commands. So when you this is the interactive mode of Scapy, but you can write the code uh, in a file and run the file with the Python. So if you like that, you should put this the import a library from Scapy that all import everything, and this is the samples. Ethernet frame get this header, the packet, the frames, and show. So let's do this. So either okay, just the ETH and uh, okay ETH the method show. Yes. So there are default values displayed. And how about the second IP packet, the IP and TCP and show. So we can see the contents of the packet in this way using the show method. So IP uh, packet IP. Yeah, that's default values. And also TCP. So they're very easy to use this library. This is a sample of the creating the packet Ethernet slash IP slash TCP. So that's the real the order of the protocol stacks, right? TCP IP layers from the Ether, IP, and TCP. So we can make this packet try. Um, and the packet show just okay, let's copy and paste and packet show. Yes, this is the complete packet using this input value. So from the Ethernet packet and IP packet and TCP packet. Okay, and then we can send the packet using the functions. Um, Send p, and we have two functions: send p and send. There's some uh, differences. Send p is sending packet at layer 2. What's the meaning? Layer 2. In the protocol text, I maybe mentioned the data link is the first layer in the TCP/IP, but usually layer 2 means the link layer, the Ethernet layer. So they must handle the data from the physical interface card, right? That means they have to specify the interface names here, ETH0. So library import and then set up the make the frame like that, destination address and ALP uh, the protocols this way. So we can do this interactive mode. To C and to V and send the P. Yeah, but yeah, the address is not valid. Anyway, in these examples, we can see we can send the one packet to the specific address, the target. In this case, the target MAC address is all Fs. What's the meaning of all Fs? What's the meaning of all Fs? That is not your grade. That's a broadcasting address. So this packet will send on the broadcast of the network. So everyone will receive the packets. Okay. Okay, that's all for today. Let's continue on maybe after the break, spring break. Thank you.